Welcome back. It's all very exciting, as always. I have to say, a new project, a bespoke project, another one which is great. This is the chronological engine. I do seem to be using that word a lot for my different projects. This one came about simply because I was thinking clocks always go round and round. What would happen if they didn't? Hence the fact that the hour hand can only go around to 12 there, then it has to return back, and the minutes are displayed on this dial, and each time, every minute when this dial moves, you get a little flickering effect in there, which is nice. And it's got a PIR sensor there, so that when it doesn't see any movement, the lights fade down. And if you've watched the original videos, in fact, there we are, look, it's going to move, there's the minute hand moving. It took ages to work out how to illuminate this with, in the end, some little surface mount LEDs that I fitted onto a wire harness. Anyway, we'll get to that later. And then you control it by, for example, set chronograph alarm, there we are. And this one also has a bell, so it can have a passing strike or a counted strike or no strike. It's got a countdown alarm, it's got all sorts of different things, set chronograph time. The adjustments are made using this. So what Erin wants, and what we've talked about and discussed and on some drawings of, is we're not going to have this thing here, we're going to have a little map, a line outline of USA, and these controls will change slightly so that it's very easy for her to set which one of the time zones she's currently in, and then the clock will respond to that. And also she can't have a dinging alarm, because in a truck obviously it's going to be going along and bumping around all the time, so that's going to be ringing. So we're going to have a really nice, some sort of lovely flickering flame effect lamp that comes on, and a flute, which is actually something like a cuckoo flute from a cuckoo clock. A flute that's going to keep going as a nice gentle wake me up alarm. So that's the plan at the moment, and I'm going to hopefully lead you through its manufacture from nothing right up to the finished item. Also she's not going to need the PR sensor, because obviously she's got 2 dogs, and obviously that would be set off all the time, and she's going to have some other storage bits around the back and all sorts of other things. Slightly smaller space, so probably not have all this copper on, but regardless of anything else, I can build this bit, which I can't wait to start. Fabulous. I'll demonstrate the fading up effect by unplugging everything. And then obviously it has to be logarithmic, so it's a nice gentle even fade up. There we are, it's going to find 0 and do all of its bits. The other good thing is that it's got a real-time clock in it, battery backup. So basically, even if it's unplugged, disconnected from the power supply, it'll still remember the time. And that noise is just my climatic revelator starting up as well. And over there is the Gregorian scribbulator that's just started to write today's date, because they're all connected together. I never learned, do I? How ridiculous. Again, got the 10mm thick acrylic to cut out and the laser cutter. Although I know this time I'll be clever and I'll sit it on the grill so the beam, once it goes through, gets out of focus before it sets fire to the laser cutter again. And of course I started by doing that bit and I could see the little dimples in the back wherever it was resting on the grill, where the laser bounced back. So I just wish I would remember, just wish I would follow my own instructions. So I've resorted to using the white cardboard, which is fantastic, because it soaks up any of the leftover laser that would otherwise set fire to things, and it bounces some of the laser back off it, which puts a nice radius, an even radius around all the bottom cuts. It works so nicely. This is what we're cutting out. They're the supports, 3 of them, that hold the clock in place and look rather nice, if you don't mind me saying. I've had to change the design of this one because I want a motor holder here to work the flute, the bellows pad flute, so I've had to change that, and obviously we don't need the bell on it. I'm taking the flute mechanism, which is that, from the barometric prognosticator that uses it with the aid of a sort of like swanny whistle, with the aid of a Scotch yoke to change the pitch, so it plays a tune of the last 24 hours of weather readings. And it's worked by a motor that's fitted in one of these plumbing fittings, so I'm going to, as I know it works, I'm going to use that. That's one of these, very useful. They spray up beautifully and they're the perfect size to fit a little motor inside. They're also doubly useful because even when they're all glued together, you can still get to the motor by unscrewing the front if you need to service or change it. Very useful, and they come in a variety of sizes with nice little knurled bits. Sprayed up brass, it looks beautiful. Here we are, all cut out and stuck to the, oh perfect, look at that. It works really well. I mean, admittedly you get bits of card stuck on the back, but not that much really. Let's see if I can zoom in. And you can see the slight radius. Yeah, well, there's a slight radius. Isn't that amazing? It's a top tip if ever there was one. Here are the 3mm thick base parts, and as always, if I zoom into that, you can see that the red lines are actually made of lots of little ones, which I'm cutting to much lower power, so they just turn out as engravings. Right, let's get that cut out. If you are interested and have a laser cutter, to engrave lines that are 0.15mm apart, I set it for 40mm a second at 15% power, that's with a 60-watt laser, and to cut 3mm acrylic is 10mm a second at 40% power. Right, the moment's truth. Now I vaguely remember having had problems with these and those, but it was so long ago I can't remember what they were. Let's try this first of all. There's the plumbing fitting. Yeah, that's too loose. Oh no, actually I think I cut the back off. It's a bit loose. Oh well. Right. Complete failure, hopefully. Oh, that's good. That fits. It's not too tight. I'm sure I remember it and it's just too tight, whereas that's fine. Now, a nice thing about using this system to fix the clock down is that I'm going to have a screw through the middle as well into the side of the clock, the spun metal bit, and a screw down through a drilled hole here into the base. So it's really, really strong, very rigid. And then we've got that one. Good, lovely. And finally, I can't see why this wouldn't fit as it's identical. Great, right. I'll get them cleaned up and the holes drilled. Oh, and the last bit I cut out was this. And this is what I used to fix the side on. Hold on a minute. I'm wittering on about clocks and stuff. The clocks I use are Werktig. And I don't think Ikea sell them anymore, which is why I ended up, as I saw the numbers diminishing and got all these projects planned around this spun metal thing, and they weren't very expensive, so I bought quite a lot of them. But they're perfect. I'll show you why. Here's one I took or opened earlier and started taking to pieces. Absolutely fantastic, because you get a spun metal case, which is great, and it's got a matte finish which helps the glue stick. It's also the paint to stick. It's also got the back held on by 3 really nice reusable springs. Absolutely brilliant. And then just keeps getting better. I've already taken the clock movement off this and peeled the inside out. It's got this really nice rigid plastic tray, which which is perfect, and then a piece of glass, so it's ideal, absolutely brilliant. Right, I'm not going to put all that back together. What I'm talking about though, what I was going to illustrate was with these supports, doesn't matter if it's the wrong way around, I carefully originally mapped the profile of this so that what it does, you see that, it sits like that, which is lovely, works really nicely. Now this bit, oops, this I'm going to tap with a nice big tap to take a plumbing fitting so I can fix copper pipe to it, because obviously any self-respecting steampunk machine, clock type thing, would have some other connections, and this is going to sit on the side. Cunning plan, another excuse for a jig, well, any excuse for a jig, is something that will stress the bearings on my pillar drill to the extreme. It's a big sanding disc with the right profile put on it, the same profile as is on the edge of that. So I will demonstrate, show you how to do that when I come to do it, but that means that once that's sanded on here, that will then sit perfectly against the side, and I can screw that on and then fix the plumbing fittings. Anywho, first things first, I can't remember what that is. You go away and have a think. I fancy doing a little bit of tapping. Here's the tap I bought, especially for this purpose. I think it's a 1/2 inch one, which is the plumbing fitting size. That is, in fact, it relates to the standard thread size on 15mm pipe, so it's that thread, which is great. So what I'm going to do first of all, because I'm now finally remembering, it's coming, I wouldn't say flooding back, dripping back, I'm remembering what this part of this jig for and how that part relates to that part. What I've remembered is, so if we remember, this has the right angle, the same as the clock surround face style thing, enclosure. This bit, and the clue is in the sanded end of this. Once I've tapped this, I then screw that on that, clamp this down to the pillar drill, then I can just offer this up against that wheel and it sounds the right angle, the angle of the dangle, without me having to try and grip this and keep it perpendicular and all the rest of it. So now I'm trying to remember how on earth I got that perpendicularly through here. I'm going to go and try and use the lathe and see what happens. As always, it's very cramped around here. Now this tap has got such a huge shank on it that it will only really fit in the chuck of the lathe. I'm going to use the front of the drill bit chuck to hold this flat, and I'm going to use this bit, the tool holder, to stop this rotating. Like I say, I can't quite remember how I did this before. There you go, look at that. Now, because, as I say, this for 15mm pipe, this 1/2 inch, whatever the thread is the same for all of these brass fittings. So there's all sorts of exciting fittings you can get, 15mm size. So that was one that reduces, a compression fitting that reduces 8mm tube down to 15, or up to 15. There's a, I think this is a leak repair thing that you slide over a leak. So again, same thread, different sort of look, or there's ones that directly, I think this is a tap connector again, to prove a point. They're the standard size that fits into this thread, which is really useful because it means that you can interface, to sound really poncy, you can interface plumbing fittings with 10mm acrylic and things. There you go. I'll stop talking about that, as I think I've proved the point, and I'll try and work out, or will set this up to sand the angle of the dangle. So there we go, we've fixed this abrasive wheel into the pillar drill, and I've taken the precaution, and call me old-fashioned, but having this speeding round at whatever I usually use is probably not going to be very good for my health, so I've slowed it down really nice and slow, a bit like, well, these are like, well, same principle as derailleur gears on a bike. So you've got 3 lots, and they are pulleys, and there's a nice little chart to show you which speeds you can achieve. Quite why you need so many different speeds, I don't know. Just fast, medium and slow would probably suffice. Right, the moment of truth. Nothing's flown off. We've got the angle down there and the angle around here, so let's go and try it against the clock. Right, there's the spun clock side, that's it. Oh, well, that's not bad at all. Took me goggles off. That's okay. Right, I need to make some decisions about height, because the motor that's going to go here to work the bellows and the flute, I don't want it to bang into this pipe with the pulley on it and things, so I'm going to arrange everything. I haven't got the baseboard because I don't know the size yet. These gate valves are brilliant, 15mm gate valves. Later on in the project, or another video or whatever, I'll show you how to include an encoder to remove the guts of the gate valve, replace it with a very small encoder which allows it to still operate, and you can make adjustments via an Arduino or similar. So it really is lovely because you still get to turn a proper knob, so to speak. We're connected to copper pipes, but oops, these always arrive with a coating of silicone grease. Not obvious, just enough so it gets everywhere. It just feels so horrible, so I'm just cleaning this with some isopropyl alcohol in the vague attempt that I don't get it all over everything, because then if I'm touching other stuff that I'm going to paint, it could stop the paint from sticking. And also it smells nice. That's like isopropyl alcohol, by the way. It's all coming flooding back now. I remembered what this jig does. It's even got it written on it, clock body drilling support. And that little circle there reminded me that I drilled out the middle of this piece where this is going to go. Like so. Well, so far I've just marked, I've marked the 2 holes with a pencil and then just drilled them out to 4.5. And now I've centre punched, no I haven't. These are good centre punches. They're spring loaded, so you can just line them up with the middle and they click and make a little indentation. Right, so this jig should, I've sped the drill up again. Let's see. That's it. Look at that. That would not have been possible, because I know I've tried, without adequate support. So this just having a little bit of a radius sanded on it gives it perfect support, and then you can use the hole cutter thing. Now to use one of my other favourite tools, which is the deburring tool. It's fabulous. As if you watch previous videos, you'll know that I use it on all copper pipe fittings now. It is just glorious to use. It turns a really unpleasant task using files or something or other into just a joy. It really is. I can recommend them. They even work on very small holes. Just lovely. Absolutely fabulous. Right, I'll get the thing adapter screwed on and then we can start lining bits up. I've also realised that there's the flute needs to go the other way around, the bellows, and I seem to remember anyway I paint this silver, so I want to cut this top bit off the bellows. Beautifully made. Lovely. And then the motor's going to lift it up, and then gravity, possibly with the aid of a weight on it, will play it. Now I'm gradually getting all this sorted out, which is great. Now I'm going to drill a hole to mount this motor in again to help me sort out heights and things, because to fix onto this motor use one of these, which I was very pleased to discover. I think the motor has got a 2mm diameter shaft. This is a 2mm clamp thing, I think for propellers. It's something to do with model making. Again, it's so long ago since I bought any of these. Luckily I've still got some floating about, but they're great because as you tighten them up, this forces down on sort of a chuck device which clamps really tightly. The purpose of this motor is never going to go right round, it's just going to go far enough to lift up the bellows to play the note. So first thing is to drill a hole in the middle of this bit, and I thought it's worth mentioning. It may well be edited out, but it's always difficult to keep these videos down to a sort of reasonable length. But this is a centre finder, and you just simply rest it over some circular object and it allows you to mark the centre. Take my word for it, hopefully. It's going to drill that out to 6mm. Look at that. Even that quick nasty jig I made, which was just simply a piece of wood with a few pins put in it, is coming in useful again. It just shows you. Just lined it up with this, clamped it all down, and now I can drill holes in the side clamps in exactly the right position on all of them without having to mark each one out individually. Great stuff. Now the next thing I need to do is to work out where to drill. Now I've drilled these out, I have to drill the mounting holes on the side of this. I've got 3, 45 degrees there, 45 from the centre or whatever, and another one there. And this one hasn't got one on because that's where the switch goes. And in the past I've cut out all sorts of complicated jigs and stuff, but this time I thought, put on a bit of paper, draw around it, protractor, blah 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 blah, and then you can move the measurement up the side by using a square roughly at right angles to that line that I've marked on the base, and a pencil just to draw the line, and that will indicate where to line this up and where in turn to mark and drill the hole. And I'll get these, as I said before, I don't know how big the baseboard's going to be exactly, so I'm going to get these put on, and then I've got that basic starting point. A little bit of an unorthodox pencil sharpening session later. Now I have a pencil that I can poke through the hole when I get it lined up, so I can mark where to drill the holes. Right, but just in case these aren't, despite using the drilling jig, just in case they're not, I'm going to label each one. So that's A, and I'm going to put a little A there. And there's the hole. Just in case, one of those things, you make assumptions, then you suddenly find that actually they don't quite line up. So hopefully that'll solve the problem. Brilliant. Well, I'm very pleased with that. These are now screwed on with the brass screws, and in fact I'm now thinking about whether to fix them on possibly with a bit of additional glue and then spray them all up together. That might be a plan, Stan. There's the motor that I'm now going to try and work out the height for. That's going to be dictated, and it's fascinating when you're designing things like this, because if you take it logically, it really has to follow a certain sequence of events, because I'm going to have a thread, a little mini chain that comes from this pulley and the motor up over a pulley here and then down here to open the bellows. So I know that the pulley is going to have to be somewhere like that. It doesn't really matter about X and Y, all I'm concerned about is Z, because I now know the pulley has got to be higher than this copper pipe. So that is what's going to dictate how high this is. So I'll work that out and then get back to you. Oh, and there's I've cut the top off the flute thing, the cuckoo thing, so I could turn it round, because originally it was this way and I want it to be that way, so that the chain can pull this. Give me a moment. Can pull this side open and close to the bellows. What I also might do, I might leave this as wood. I mean, this doesn't matter, the height, because I can make some nice attractive standoff for that. The important thing is that copper pipe. So I'll work that out, and then I'll get this cut down. Lathe, you see? Nah, mate. I've marked it on there. there, and I've measured that 35, and I've set this to 35. It seems to be leaking again. So and there we have it. Brilliant. So that's now 50mm above the base, and I'll have another pulley somewhere over there, not stuck on a rod like that, but somehow, and then that means I can line that up with there, bring this forward, and then it'll all line up beautifully. Excellent. Thank you very much for watching, and next time possibly how to start working on the inside of the clock, illuminating a clock that doesn't go right the way round, stepper motors and other bits and pieces, flickering lamps and all sorts of exciting stuff. Hope to see you then. Thanks again. Oh, remember to click subscribe. Apparently I meant to be saying that. Thank you.